Let's start by defining what a data analyst actually does. Basically, it's about taking all the messy information a business collects, sales figures, website traffic, customer feedback, and making sense of it. We're looking for patterns, trends, and insights that can help people make smarter choices. A data analyst is like a detective, piecing together clues to reveal what's really going on. Let's talk about what a data analyst actually does. They're not just number crunchers, they're detectives of data. Their job starts with collecting information from all sorts of places, like databases and spreadsheets. Then, they need to make sure that the data is clean and accurate, which means fixing any mistakes or missing pieces. Once the data is ready, they dive in to explore it, looking for interesting patterns and trends using tools like statistics and visualizations. They then package these findings up into reports and dashboards, making them easy to understand for everyone involved. And importantly, they work hand in hand with other teams to make sure their insights are actually used to make a difference. Okay, let's talk about how a data analyst actually works. It's not just crunching numbers, it's a structured process. We start with understanding the business need. What problem are we trying to solve? Then, we gather and prepare the data itself, which can be tricky. Next comes exploration, digging into the data to find interesting patterns. After that, we build more complex models to confirm our findings, and finally, we communicate those insights and translate them into real-world actions. Okay, let's talk about the different kinds of data we encounter as a data analyst. First up is structured data. Think neatly organized information like customer details in a spreadsheet or sales records. It's perfect for using SQL to quickly pull out exactly what you need. Next, we have semi-structured data, which isn't quite as rigid as structured data but uses tags to give it some meaning, like JSON files or even CSV with slightly inconsistent headers. Finally, there's unstructured data, things like emails, social media posts, and videos that don't fit into any specific format. Analyzing this kind of data requires more advanced techniques. Okay, let's talk about how we actually get our data. There's a whole range of ways to collect information, and it's important to choose the right one for what you're trying to achieve. We often start with surveys or questionnaires. These are really good for getting opinions and structured responses from lots of people. Then there is web scraping, which involves pulling data directly from websites. Database queries, particularly using SQL, are essential for accessing information stored in databases. And increasingly, we're using API to connect to external services like social media or even IoT devices that are collecting real-time sensor data. It's all about getting the right data and making sure it's reliable and ethically sourced. Okay, so after you've gathered your data, it's rarely perfect. That's where cleaning and pre-processing come in. Think of it as tidying up a messy room. You need to get everything organized before you can actually use it. We have a few key things we need to do. First, handle missing values, deciding what to do when there are gaps in your data. Then, get rid of duplicates, ensuring you're not counting the same information twice. Next, fix any errors, typos, formatting issues, and downright incorrect entries. Finally, standardize or normalize your numerical columns so they're on a similar scale. And don't forget to make sure all your data types are correct. All this groundwork sets the stage for accurate analysis. Okay, let's talk about handling missing data. It's a really common situation when working with datasets. The first thing to do is understand why those values are missing. Were they errors during collection? Are they simply not applicable for some records? Once you know the reason, you have different options. You can sometimes just remove rows that have missing values, but be careful because that could introduce bias if it's a significant amount of data. Another approach is imputation, basically replacing those missing values with estimates. There are several ways to do this. Things like using the average or median for numerical columns, or the most frequent value, the mode for categorical ones. Regression imputation is more advanced and uses other variables to predict what the missing value should be. And sometimes, it's actually useful to create a new variable that simplifies whether a value was originally missing. This can preserve information about why the data went missing in the first place. Okay, let's talk about data validation. It's a really important step in being a good data analyst. Essentially, it's making sure your data is actually good before you start analyzing it. Why do we need to do this? Well, if your data has errors or inconsistencies, any insights you draw from it could be completely wrong. We've got some common techniques like range checks, making sure a number falls within an expected range, format checks to verify things are in the right shape like email addresses, consistency checks to see if everything makes sense together, completeness checks for missing data, and uniqueness checks to avoid duplicates. There are lots of tools we can use: SQL constraints, Python libraries like pandas, and even simple validation features in spreadsheets. Basically, it's all about catching those errors early. Okay, let's talk about exploratory data analysis, or EDA for short. Think of it as your detective work. You're trying to understand what the data is telling you before you start building anything complex. We'll be looking at things like cleaning up any errors in the data, taking a close look at individual variables to see how they spread out, and then examining how those variables might relate to each other. It's really about getting a feel for your data set and figuring out what's worth investigating further. Okay, let's talk about how we describe our data. Descriptive statistics are all about summarizing what we see. We have the mean, which is just the average, a simple way to find the center of your data. Then there's the median, which is like finding the middle number when you line up all your values. The mode tells us which value appears most often. Next up are standard deviation and variance. These measure how spread out your data is from its average. A higher standard deviation means your data points are more scattered, while a lower one indicates they're clustered closely around the mean. Understanding these will give you a really good sense of what your data looks like. Okay, so we're moving into inferential statistics, basically how data analysts use samples to make broader statements about populations. We start with hypothesis testing, which is like a formal way of questioning something. Think of it as trying to prove or disprove an idea. We set up two competing ideas: the null hypothesis, which says there's no effect, and the alternative hypothesis suggesting there is an effect. Then we look at p-values. They tell us how likely our data is if that first idea were actually true. A really small p-value means we can confidently say to reject the idea. Next up are confidence intervals. These aren't just random guesses, but rather a range of values where we think the real population number lies, and we give ourselves a percentage chance like 95% that it's inside that range. Okay, let's talk about transforming your data. Think of it like prepping ingredients before you cook. You need to clean them, cut them up, and organize them. Data transformation is all about taking raw, messy data and turning it into something usable for analysis. We'll cover some key techniques: cleaning up errors and missing values, scaling data so everything's on the same level, summarizing large amounts of information, focusing in on specific data groups with filtering, and combining data from different sources together. Remember, the best transformation methods really depend on what you're trying to achieve. Okay, let's talk about outliers, those data points that just don't fit in with the rest of the crowd. They can be tricky because they might be genuine extreme values or simply errors. We'll look at a few ways to spot them using things like statistical measures and visualization techniques. Then we need to think about what to do with those outliers. Sometimes you want to remove them, but other times transforming the data or capping the values can be better options. And remember, sometimes an outlier is actually really important. Don't just blindly delete it. Okay, let's talk about normalization and standardization. They are really important steps in preparing your data for analysis. Think of them as ways to make sure all your numbers are playing on a level field. Normalization scales all your values so they fall between 0 and 1. It's great when you have features that measure completely different things, like height and weight. Standardization, on the other hand, shifts and stretches your data so it has a mean of 0 and a standard deviation of 1. This is really helpful for algorithms that are sensitive to the scale of the input data. There are a few common ways to do this. Min-max scaling just adjusts everything between 0 and 1, and Z-score standardization centers the data around 0. Ultimately, the best approach depends on your specific dataset and what you're trying to achieve. Okay, let's start with SQL. It's a really important skill for any aspiring data analyst. Think of SQL as your language for talking to databases. Databases are like digital filing cabinets that store all sorts of information. SQL lets you ask specific questions and get exactly the data you need. We'll cover some core concepts, like tables, which are basically organized spreadsheets, columns representing the different attributes of each entry, and rows holding individual pieces of information. And finally, queries. These are your requests to the database for the data you're looking for. Okay, let's dive deeper into SQL. We're moving beyond the basics and looking at some powerful techniques that will really help you as a data analyst. First up are joins. These allow us to bring together information from related tables, which is often essential for getting a complete picture. Then we have subqueries, essentially queries within queries, allowing for very targeted filtering. Window functions are all about analyzing data in its context, without needing to group it. Think of things like ranking customers or looking at previous values in a row. Next, CTs. They're like mini queries that you can reuse throughout your larger SQL statements, making them much more readable and organized. Finally, we have views. These are essentially saved queries that encapsulate complex logic, ensuring consistency when accessing data. Okay, let's talk about data warehouses and how they handle information. We have two main types of systems we need to understand, OLTP and OLAP. OLTP, or online transactional processing, is like the engine of your business. It handles all those real-time transactions you experience every day, things like buying something online or making a bank deposit. It's super fast and accurate for individual events. Then we have OLAP, or online analytical processing. Think of this as your business intelligence tool. It's designed to analyze large amounts of historical data, like looking at sales trends over time. The key difference is that OLTP focuses on doing things quickly, while OLAP focuses on knowing what's happening based in the past. Both are vital for a data analyst. Okay, let's talk about ETL. It's a really important process for any data analyst. Basically, ETL stands for extract, transform, load. Think of it like building a house. You start with raw materials, the data, then you shape and refine them into something useful, and finally, you put everything together in its final place. Extraction is just pulling the data from wherever it's sitting, databases, spreadsheets, even logs. Then comes transformation. This is where you clean up messy data, make sure everything's consistent, and get it ready for analysis. Finally, you load that transformed data into a central location like a data warehouse. There are lots of different tools out there to help with ETL, from Apache Kafka to Talend, and even cloud-based solutions like AWS Glue or Azure Data Factory. Okay, let's dive into data modeling. It's all about creating a clear picture of your data, like a blueprint for how it's organized and used. We start with entity relationship diagrams, or ER diagrams, which show the connections between different things you're tracking, such as customers and products. Next, we look at the star schema, a really popular design for data warehouses. It centers around fact tables that record events and dimension tables that give context to those events. Think of customer information alongside sales figures. Finally, there's the snowflake schema, which is like a more refined version of the star, breaking down dimension tables into smaller, related ones. This can be helpful when you have lots of redundant data. Okay, let's talk about how to make your data visualizations really shine. The most important thing is clarity. Think about what you want people to take away from the chart. Keep it simple, focusing on one key message at a time. Accuracy is also vital. We need to be sure our charts are telling the truth about the data, and always provide context so everyone understands what's going on. Okay, so we've done the analysis. Now what? It's not enough to just present a bunch of numbers. You need to tell a story with your data. Start by thinking about who you're talking to and what they care about. Then grab their attention with a surprising statistic or question. Next, use visuals like charts and graphs to make it easy for them to understand the trends. And finally, structure your presentation like a proper narrative, set the scene, explain your findings, and offer clear recommendations. Remember, clarity is key, avoid technical jargon and focus on why the data matters. Basically, you're turning data into actionable insights. Okay, so let's talk about chart types. Choosing the right one can really make a difference in how people understand your data. We have bar charts, which are fantastic for comparing different categories, like looking at sales by region or website traffic from various sources. Line charts are brilliant for spotting trends over time, things, stock prices, or how many users join your platform each month. Pie charts are good for showing proportions of a whole, but they can get messy if you have too many slices. Scatter plots help us see relationships between two variables, like age and income. And finally, area charts show cumulative totals, really great for seeing the build-up over time. Okay, so as a data analyst, you'll be spending an asterisk of time turning numbers into stories. And visualization is key to making those stories clear. We've got some popular tools that help us do just that. Tableau is amazing for really interactive dashboards and powerful analysis. Think big business reports. Power BI integrates seamlessly with Microsoft products, which makes it super easy for lots of people to use. Excel is still a solid choice, especially when you need something quick and familiar. And Google Data Studio is fantastic if you're already using Google tools. It's free, collaborative, and great for sharing your insights. Let's talk about making data dashboards that actually work. The key is to keep things simple and focused. Start by selecting only the most important metrics, those that directly reflect your goals, not just what looks good. Then declutter. A dashboard crammed with unnecessary information will overwhelm users and make it difficult to identify trends or insights. Think about how you want people to see the data. Use size, color, and placement to draw their attention to the most crucial elements. And finally, don't be afraid to add interactive components like filters, but do so strategically. Too many options can be just as confusing as no options at all. Okay, so let's talk about KPI. They're basically the scorecards for your data analysis work, and really important for showing how you're impacting business results. First, we need to pick KPI that directly connect to those overall company goals. Think of it like this: what are we really trying to achieve? Then each KPI needs to be smart, specific, measurable, achievable, relevant, and time-bound. Don't just say improve sales, aim for something concrete like increase monthly sales by 10% in the next quarter. Next, you need to know where your data is coming from: CRM, website analytics, whatever it takes. Finally, decide how often you'll be checking in on those KPI: daily, weekly, or monthly, depending on how fast things are changing. And don't forget to share your findings with the team. Okay, let's talk about ad hoc analysis and reporting. It's all about tackling specific questions that pop up unexpectedly. Think of it as being a detective for data. When someone needs to understand something quickly, like why sales dipped last month or what factors are driving customer churn, that's where ad hoc analysis comes in. It starts with getting a clear understanding of the question: what's really going on? Then you gather the right information from different places, often using SQL to pull data together. Next, you start exploring this data, looking for patterns and trends using tools like pivot tables or creating visuals. Finally, it's all about communicating your findings clearly with charts and dashboards so everyone can understand what you discovered, and crucially, what actions should be taken. Okay, let's talk about getting your data insights in front of the people who need them. Creating reports and dashboards for stakeholders is a crucial part of being a data analyst. First, you really need to understand who you're presenting this information to. What are their goals? What questions do they have? Then think carefully about how you'll visualize your data. Charts and graphs often speak louder than just numbers themselves. Don't overload people with too much detail. Focus on the key takeaways. And finally, consider building interactive dashboards so users can explore the data for themselves. Okay, let's talk about data governance and compliance, specifically GDPR and HIPAA. As a data analyst, you'll be dealing with lots of information, some of which is really important to protect. Think of it like this: data privacy isn't just about laws, it's about building trust. GDPR mainly affects people in the European Union, and it makes sure they have control over their own data, things like knowing what's being collected and having the ability to delete it if they want. Then there's HIPAA, which focuses on protecting health information here in the US. Now, you don't need a law degree to be compliant, but understanding these principles is super important. It's all about collecting only what you need using techniques like anonymization or pseudonymization when possible, and making sure that data is stored securely. Okay, let's talk about databases, specifically the relational kind, which are super important for data analysts. Think of them like organized spreadsheets on steroids. We're covering the big four: MySQL, PostgreSQL, SQL Server, and Oracle. They all store information in tables with rows and columns, making it simple to find exactly what you need. MySQL is a really popular choice because it's free and fast, while PostgreSQL is known for being super reliable and having lots of advanced features. Then there's SQL Server from Microsoft, which many businesses use, and Oracle, a heavyweight that's used by some of the largest companies in the world. Each one has its own advantages, but they all follow these basic rules about how data is organized. Okay, let's talk about NoSQL databases. These are different from the traditional SQL databases you might be familiar with. We'll look at two popular ones, MongoDB and Cassandra. MongoDB is a document-oriented database that stores data in flexible JSON-like documents, which makes it really good for things like user profiles or product catalogs where the structure isn't always fixed. It's also super scalable. And then we have Cassandra, which is designed to be incredibly reliable and handle massive amounts of data distributed across multiple locations. Think about things like tracking sensor readings. That kind of time series data does really well with Cassandra. So, understanding these differences is key when choosing the right database for your project. Okay, let's talk about big data. We're moving beyond just dealing with lots of information. Big data is all about huge volumes of data arriving at incredible speeds, in many different forms, from structured spreadsheets to images and text. Think of it like this: you have a massive warehouse full of boxes, and you need to analyze what's inside them quickly. Hadoop was one of the first big tools used for this, storing data across lots of computers. It uses something called MapReduce to process that data in stages. Then came Spark. It's similar but super fast because it can store a lot of information in memory instead of always needing to read from disk. Okay, let's talk about using Excel for data analysis. It's a fantastic way to get started. First off, sorting and filtering your data is really important. It helps you quickly find what you're looking for. Then, you can use formulas and functions to do some basic calculations and see how things are trending. Pivot tables are super handy because they let you summarize information in a dynamic way, almost like testing what-if scenarios. And of course, don't forget about charts and graphs. Visualizing your data makes it much easier for others and yourself to understand the key takeaways. Excel is a great foundation, but keep in mind that as your datasets grow or you need more advanced analysis, other tools might be better suited. Okay, let's talk about pivot tables and pivot charts. They're a huge part of being an effective data analyst. Basically, a pivot table is like a super flexible spreadsheet where you can rearrange your data to see different perspectives on it. You drag fields like customer names or product categories into rows, columns, values, and filters. It's all about quickly summarizing the information in your dataset. And then, if you want a visual representation of that summary, you create a pivot chart which is directly linked to the pivot table. These charts make it really easy to spot trends and patterns. Think bar graph showing sales by region or pie charts illustrating market share. Okay, so let's talk about how Excel can become a serious data analysis tool. We're going to focus on two powerful add-ons, Power Query and Power Pivot. Power Query is your go-to for getting messy data into Excel. It's like an ETL system. You can pull data from all sorts of places, clean it up, and get it ready for analysis. It uses something called M-code, which you can learn to write if you need super customized transformations. Then there's Power Pivot. This builds data models within Excel so you can combine information from multiple sources, create relationships between them, and perform some really powerful calculations using DAX. That's a special language for working with data in Excel. It's great for building interactive reports and dashboards. Think bigger than just simple spreadsheets. Okay, let's talk about how Python helps us analyze data. First up is NumPy. It's like the bedrock of numerical computing in Python. Think of it as a super efficient way to store and work with large amounts of numbers, especially when you need to do calculations quickly across many values at once. It also introduces this concept called broadcasting that handles different sized arrays beautifully. Then we move on to Pandas, which takes things a step further by introducing data frames, essentially tables of data, just like spreadsheets, but much more powerful and flexible for analyzing information. Okay, let's talk about using R for data analysis, specifically focusing on dplyr and ggplotware. Dplyr is like a super efficient toolset for cleaning and shaping your data. Think of it as your go-to for wrangling messy datasets. It lets you easily filter rows, select specific columns, reorder your data, and even create new calculations. Then we've got ggplotware, which is the king of creating beautiful and informative visualizations. It uses a clever grammar of graphics so you can build up plots layer by layer, customizing everything from colors and labels to titles, really letting your data tell its story. Okay, let's talk about Jupyter notebooks. They're seriously awesome for data analysis. Basically, they're like interactive workbenches where you can write code often in Python or R right alongside text explanations and beautiful charts. You can run your code directly, see what happens instantly, and document every step of your process, making it really easy to share your findings with others. It's a fantastic way to explore data and tell a story about the insights you uncover. Okay, let's talk about statistical testing. It's a core skill for any data analyst. Basically, these tests help us figure out if we can truly say something is significant in our data, not just random chance. We have a few key players: the t-test, which compares two groups; the chi-square test, great for looking at relationships between categories; and ANOVA, which lets us compare more than two groups. Remember, each one has its own rules. Getting the right test applied to your data is what makes your analysis really shine. Okay, let's dive into correlation and regression analysis. They're key tools for data analysts. Correlation tells us how two variables tend to move together, whether they go up or down at the same rate. It's important to remember that just because two things are correlated doesn't mean one asterisk causes asterisk the other. Regression, on the other hand, is all about prediction. We use it to build models that can forecast a value based on other factors. For instance, we could try to predict sales based on how much we spend on advertising. I've included some basic Python code here to show you how regression analysis might be implemented. The model summary will give us valuable insights like the R-squared score, which tells us how well our prediction is fitting the data, and also p-values that tell us if our predictors are statistically significant. Okay, so let's talk about time series data. It's basically information that gets recorded over a sequence of events. Think about things like stock prices changing daily or website visits throughout the week. This kind of data has a trend, which is the overall direction it's moving in, whether upwards or downwards. Then there's seasonality, where you see repeating patterns. Maybe sales jump up every December because of holiday shopping. You might also notice cyclical patterns that don't follow a set schedule, like how economists tend to go through booms and busts. Finally, there's random noise, just unpredictable fluctuations. Recognizing these components is the first step in working with time series data. Okay, let's talk about sampling. When you're dealing with huge amounts of data, it can be really tough to analyze everything. That's where sampling comes in. We essentially pick a smaller group that represents the whole dataset. Random sampling gives everyone an equal shot at being included, perfect for unbiased results. Stratified sampling breaks things down into groups based on characteristics like age or income, making sure we have good representation from each segment. Cluster sampling involves selecting entire groups of records, which is handy when data is spread out geographically. And finally, systematic sampling picks records at regular intervals. It's all about finding a balance between accuracy and efficiency so you can get meaningful insights without overwhelming resources. Okay, let's talk about business metrics. They're super important for a data analyst. Basically, they are measurable values that show how well the company is doing in relation to its goals. Think of things like revenue or customer acquisition costs. Those are metrics. But it goes deeper than just knowing the number *. Analysis involves looking at trends and patterns within your data to understand why something is changing, maybe a dip in sales or a sudden spike in website traffic. Understanding these changes is key to making smart decisions. Okay, let's dive into the basics of financial analysis for data analysts. It's really important to understand how businesses are making and using money. We'll start with 3 core statements: the income statement, which shows profit over time, the balance sheet, a snapshot of what a company owns and owes, and finally, the cash flow statement, tracking all cash movement. Then we'll look at some key ratios like profit margin, telling us how profitable a business is, debt to equity, showing how much they're relying on debt, and the current ratio, which shows if they can cover the short-term bills. Understanding these basics will help you interpret your data in a whole new way and draw more powerful conclusions. Okay, so you've noticed something could be better. Maybe a website page isn't performing as well as it should. That's where /B testing comes in handy. It's basically like a mini competition between 2 versions of something, and we want to see which one wins. We're talking about comparing things like headlines or button colors. To get started, you need to clearly define what you're trying to improve, your goal. Then figure out how you'll measure success. What metrics are you tracking? And it is super important that we randomly assign users to either the original version or the new version so we don't accidentally skew the results. It's not enough to just run a test for a day. Make sure you let it go long enough, at least a week, to account for any daily fluctuations. Finally, analyze the data and use statistical tests to see if there's a real difference between the 2 versions. That's how we know which one is truly better. Okay, so let's talk about customer segmentation. It's all about breaking down your overall customer base into smaller groups with similar traits. We can do this based on things like age and income, demographic data, or their lifestyle and values, psychographic information. Then there's behavioral segmentation, which looks at how people interact with your brand, like what they buy and how often. Finally, geographic location plays a role too. Combining different methods will really help you understand your customers better and create targeted strategies. Let's talk about cohort analysis. It's a really powerful tool for data analysts. Basically, we group users together based on when they join something, like signing up for a service or downloading an app. Think of it like creating little time capsules of your user base. By tracking how these groups behave over time, how many people keep using the product after a month, 6 months, or even a year, we can spot trends and understand what's working and what isn't. This helps us decide if we should tweak our marketing or make changes to the product itself. You could look at retention rates, how many users stick around, and compare different cohorts to see if one group is doing better than another. Let's talk about something really important for any business: keeping your customers around. We call this retention analysis. It's all about figuring out why people stop using what you offer, and then doing something to change that. There are a few key numbers we look at, like churn rate, which is the percentage of customers who leave, customer lifetime value, or CLTV, which tells us how much revenue we can expect from each customer, and retention rate, which is simply the opposite of churn. Understanding those metrics helps you spot problems. Common reasons for people leaving can range from bad customer service to feeling like your product doesn't really deliver. Sometimes it's even just that a competitor offers something better or that the price isn't right. By digging into these factors, you can create strategies specifically designed to keep those customers happy and coming back. Okay, let's talk about churn analysis. It's basically figuring out why your customers are leaving, a really important part of running a successful business, especially if you have subscriptions or recurring revenue. The first step is collecting data from all the places it lives: your customer relationship management system, support tickets, even tracking how people use your products online. Then we need to create some useful features, things like how long ago they last bought something, or how many times they've contacted support. We can then group customers based on similar behaviors and build a model that predicts who's most likely to churn. Finally, the really exciting part: using those predictions to take action and try to keep them around. It's all about providing the right support or offers at just the right time. Okay, let's talk about sales and marketing analytics. It's all about turning raw data into actionable insights to help businesses grow. You'll be looking at everything from individual sales figures to the performance of entire marketing campaigns. Key areas include tracking how well your sales are going, evaluating your marketing efforts, which channels are working best, and understanding who your customers really are through segmentation. Tools like SQL and Excel are essential for digging into data, while visualization tools like Tableau or Power BI help you tell a compelling story with the numbers. Let's dive into supply chain analytics. It's a really fascinating area where data analysts can make a huge difference. Essentially, we're looking at the entire flow of goods from raw materials to the customer's hands. We use historical sales and market trends to predict what people will want in the future, which helps us manage inventory effectively. We also optimize how things move around, think about delivery routes and logistics to keep costs down and ensure products are available when they're needed. And, of course, we monitor our suppliers to make sure everything runs smoothly. Okay, let's dive into web analytics. This slide covers the basics of using tools like Google Analytics and Adobe Analytics. It's all about tracking what users do on your website, how they arrive, where they go, and if they complete any desired actions. We'll talk about setting up the tracking itself, segmenting your audience for deeper insights, seeing new visitors versus returning ones, and then creating reports to show what those insights mean. Google Analytics is a really useful starting point because it's free and pretty powerful. Adobe Analytics is more advanced and usually used by larger companies with specific needs for detailed reporting. Okay, so after we collect survey data, the next important step is analyzing it. We need to get our data clean. That means dealing with any missing information or errors. Then we'll calculate some basic statistics like averages and how spread out the data is to understand what's going on. Next, we can segment our respondents into different groups based on their answers or demographics, which helps us spot interesting trends. Finally, let's look for correlations or certain features linked to higher satisfaction levels. Don't forget to visualize your findings with charts and graphs to make the insights clear. Okay, let's talk about something really important: data ethics and privacy. As a data analyst, you're dealing with sensitive information all the time, so it's crucial to think about how the data is being used. It's not just about whether your analysis can be done, it's about should be done. We need to be transparent with users about what we're collecting and why, avoid creating biased algorithms that unfairly discriminate, and always establish clear responsibility for how data is handled. And remember, we should only collect the data we truly need, a principle called data minimization. Finally, don't forget about privacy regulations like GDPR or CCPA. Knowing these laws is vital to protecting individual rights. Okay, let's talk about version control, specifically Git. Think of it like a time machine for your code. As data analysts, we often work with others, and Git lets us track every change someone makes to the project, so no one loses their work or accidentally overwrites something important. It's fantastic for collaboration. It also allows you to easily revert back to previous versions if something goes wrong, which is a huge benefit. We'll cover some basic commands like git init to start a repository, git clone to get started with an existing project, and how to stage changes with git add, followed by creating commits with a descriptive message using git commit. It's really powerful for managing complex projects. Okay, let's talk about how we wrap up our data analysis work. It's not enough just to find some interesting insights, you need to clearly communicate those insights to others. That's where documentation and presentation come in. First, meticulous documentation is crucial. It includes everything from the initial question you were trying to answer, all the steps you took with your data like cleaning and transforming it, and any assumptions you made along the way. Using version control tools like Git helps keep track of changes and allows for collaboration. And most importantly, ensure anyone can reproduce your work by providing clear instructions and access to everything involved. When presenting your findings, always tailor your approach to your audience. Use visualization, charts and graphs are powerful to make complex data easier to understand, and remember to frame your analysis as a story with a beginning, middle, and end, the problem, how you approached it, what you found, and what actions should be taken based on those findings. Okay, let's talk about automating those reports and workflows, a huge time saver for data analysts. Basically, we're not trying to replace your analytical skills, but rather free you up from the tedious tasks. Think about how much time you spend manually building reports each week. There are several ways to tackle this. First, you can schedule reports using tools like Python or BI platforms. They'll automatically pull data and generate a report for you on a regular basis. Another approach is workflow automation. Think of Zapier or Microsoft Power Automate. These connect different apps and services so that when something happens like a new customer joins, it triggers an automated action, maybe updating a spreadsheet or sending out a notification. And lastly, don't underestimate the power of scripting within your BI tool or even Excel. You can use scripts to create custom formulas and automate those repetitive steps. Okay, let's talk about making those SQL queries run faster. As a data analyst, you spend a lot of time pulling information from databases, and if those queries take forever to execute, it's going to seriously slow you down. The good news is there are several things you can do to optimize them. First, consider adding indexes. These act like shortcuts for your database. Next up, look at rewriting your queries. Sometimes a simpler approach using inner join instead of a full outer join can make a huge difference. Filtering data early on in the query also helps reduce the amount of work the database needs to do. Finally, always avoid selecting asterisk everything. Asterisk only grab the columns you truly need. To really understand where the bottlenecks are, use tools like Explain Plan to see exactly how your queries are being processed. Okay, let's talk about joins and blending. They're super important tools in a data analyst toolbox. Essentially, they help you pull information from different tables or datasets and put it together to get a bigger picture. There are several types of joins, like inner joins, left joins, right joins, and full joins, each returning different sets of results based on whether matches are found between the tables. Now, data blending is a related concept often used in larger data warehouses. It's like automating a join process, combining information that might be structured differently across sources. Think of it as bringing together separate pieces to form one complete puzzle. Okay, let's talk about data API and how they fit into the world of data analysis. Basically, an API is like a menu at a restaurant. It tells you what information is available and how to ask for it. There are tons of different API out there that provide access to all sorts of data, from Google Maps locations to Twitter trends or even weather forecasts. When working with these, you'll need to authenticate, usually by using an API key, and then send specific requests to get the exact information you're looking for. The API will respond in a standardized format like JSON, so it's important to learn how to read and understand that data. Don't worry about getting overwhelmed. Start with some simpler API and work your way up. Okay, so as data analysts, we often need to grab information from different places, websites, databases, even other applications. That's where REST API come in. Think of them as addresses that point directly to the data you're looking for. They use standard methods like get, post, and put to tell us what action to take, whether it's just retrieving some info or updating something. Most API return data in a format called JSON, which is pretty easy for computers to understand. It's all about knowing the right endpoint, thus the URL path, so we can request exactly what we need. Okay, so now we're moving on to how data analysts actually get that raw information into their BI tools. It's all about connecting those systems together. First, you need to figure out what asterisk type asterisk of database holds your data. Is it something like SQL, or maybe a NoSQL database? Then, you'll gather the connection details, basically the address and login credentials for the database. Finally, each BI tool has its own way of establishing connections, so you'll need to go into the settings and test that everything is working correctly before you start building your dashboards. Okay, let's talk about data marts and data lakes. They're both important parts of how we handle data. Think of a data mart as a really well-organized section of your warehouse, designed specifically to answer particular business questions quickly. It has a set structure, making it great for reporting. Now, a data lake is more like a giant storage space where you dump all the data in its original form, whether it's structured or not. The beauty of a data lake is its flexibility. You apply the rules and structure when you actually need to analyze the data. It's perfect for exploring new trends and even using things like machine learning. Okay, let's talk about cloud data services. As a data analyst, you're going to be using these platforms a lot more and more. All's Google Cloud Platform and Azure are the leading providers. They all offer fantastic tools for handling huge amounts of data. Think of them as your analytics arsenal. Each one has its strengths. Amazon S3 is great for storage, Redshift is a powerful data warehouse on AWS, and so on. Google's got cloud storage, BigQuery is really slick for querying, and Azure offers Synapse Analytics with Azure Data Factory. It's all about finding the best fit for your asterisk needs. Consider things like cost and what your team already knows. Okay, let's talk about getting data out of those awesome API. Think of an API as a friendly waiter. It brings you the information you ask for. First, we need to figure out which asterisk API has the data we want, and what specific endpoints we can use. Most API require some form of key or token, so it's super important to get those set up securely. Then we build requests like telling the waiter exactly what you need. Finally, we have to turn that raw data into something we can actually work with, which often means passing JSON or XML. Tools like Python's request library and Postman are really helpful for this step. Okay, let's talk about data caching. Essentially, it's like creating a little memory shortcut to get your data faster. Instead of always hitting the main source like your database, you pull frequently accessed information from a temporary cache. This reduces delays, lightens the load on your servers, and makes things much smoother for users. There are different kinds of caches too. Browser caches store website elements locally, server-side caches sit on the server to speed up queries, and client-side caches are stored directly in the user's browser. Pretty handy stuff. Okay, let's talk about backup, something really important for any data analyst. Think of your data as precious information. You need to protect it. Backups are essentially copies of your data, and they're crucial because things can go wrong. Computers crash, people make mistakes, or even cyber attacks can happen. We have different types of backups: full, which makes a complete copy; incremental, which only saves the changes since the last one; and differential, which is like a hybrid. But it's not enough to just have backups. You need to know how to restore them. That's why testing your recovery process regularly is super important. The 3-2-1 rule is a great guideline: 3 copies of your data on 2 different types of storage media like an external hard drive and the cloud, and 1 copy offsite, just in case. And don't forget to document everything so you know exactly how to get things back up and running. Okay, let's talk about data profiling. Think of it as a really thorough first step when you get new data, almost like getting to know your new colleagues. It's all about understanding the characteristics of your dataset. We start with summary statistics, basically looking at things like the minimum, maximum, average, and standard deviation for numerical columns. Then, we often want to see what the most common values are in categorical columns through frequency analysis. Missing data is a big concern too, so we need to identify where those gaps are. And finally, we check for duplicates and ensure that the data types are correct, like making sure dates are really dates and numbers are actually numbers. There are some fantastic tools out there, like Pandas profiling or OpenRefine, that can help you do a lot of this automatically. Okay, so let's talk about data consistency and integrity, basically making sure the numbers you're working with are actually correct and reliable. It's a huge deal because if your data is messy or inconsistent, any insights you draw from it will be flawed, potentially leading to bad decisions. We want to understand our data really well, starting with profiling, looking at its types, how things are spread out, and checking for missing information. Then, we standardize everything like this so they're all in the same format. And when there's missing data, we need a strategy, either fill it in or remove it thoughtfully. Data validation rules are also important, setting up checks to catch errors early on. Finally, think about having clear policies and procedures for how data is managed. That's what we call data governance. Okay, let's talk about tackling really big datasets in Excel. It can feel overwhelming at first, but there are some fantastic techniques we can use to make it manageable. First, let's make sure your data types are set correctly. This helps Excel work more efficiently. Then we'll dive into Power Query, which is basically a magical tool for getting data asterisk into asterisk Excel and cleaning it up. We'll also look at how to strategically use calculated columns and some simple tricks like freezing panes to keep the most important information visible as you work. Okay, let's talk about cross-tab reporting. It's all about digging deeper into your data. Think of it as creating a mini spreadsheet to see how different categories relate to each other. We start by picking the categorical variables we want to explore, then build a table with one variable down the rows and another across the columns. Finally, we count how often each combination appears, and that's where you can spot interesting trends or associations, like whether certain browser types are more popular on mobile devices. Okay, let's talk about geospatial data analysis. It's a really exciting area that blends the world of numbers with where things actually are. Basically, we're taking data tied to locations on Earth like GPS coordinates or satellite images and using analytical techniques to uncover patterns and insights. It starts with understanding geographic coordinates, which is just latitude and longitude, and then figuring out what type of spatial data model you're working with: raster, which uses grids like maps, versus vector, which represents features as points, lines, and polygons. You'll also want to get familiar with things like proximity analysis, how close are two locations, and techniques like hotspot analysis that can help you find statistically significant clusters of data. Okay, let's talk about a common challenge in data analysis: dealing with class imbalance. It happens when you have a dataset where one category is much more frequent than others. Think of it like this: if you're predicting whether someone has a disease, and 95% of your patients don't have the disease, you'll naturally end up with a biased model that's really good at saying no, but terrible at spotting those rare cases. This bias can significantly hurt your results. We'll look at why this is an issue. It impacts things like accuracy alone isn't enough, and we need to consider precision and recall. And then, let's explore some techniques, including resampling methods like SMOTE to create synthetic examples for the underrepresented group, as well as cost-sensitive learning where you tell your model that misclassifying a rare case is more important. Okay, so let's talk about how we get data asterisk and asterisk, that's data entry and logging. It might seem simple, but it's absolutely crucial for the whole analysis process. There are still situations where manual entry is needed, especially with older systems, but you always want to be super careful and double-check everything. More often, we're using automated logging through databases or spreadsheets, which speeds things up a lot and helps avoid mistakes. And don't forget about data validation rules. These are like guardrails that make sure the information being entered is correct in the first place. Think of it like setting expectations for what good data looks like. Let's talk about web scraping. Essentially, it's a way for data analysts to pull information directly from websites, things you might not easily get through traditional methods. It's like having your own digital librarian that can find exactly what you need. We have two main tools, Beautiful Soup and Selenium. Beautiful Soup is fantastic for extracting data from static HTML pages, those that are nicely organized. But when a website uses JavaScript to load content, or if you need to interact with the site like logging in, then Selenium comes into play, as it controls a real web browser. Okay, let's talk about how Excel VBA can seriously supercharge your data analysis skills. Think of it as giving yourself a powerful assistant that works 24/7. By automating those tedious, repetitive tasks like cleaning up messy data or building complex reports, you'll save tons of time and drastically reduce errors. Plus, you can handle massive datasets with ease and create solutions that perfectly fit your analysis needs. Ready to dive into some code? Okay, let's talk about cleaning up your data. Data often comes in messy shapes and sizes, right? Regular expressions are like a super-powered search tool for text. They help us find specific patterns, think extra spaces, weird symbols, or inconsistent formats. We can use them to get rid of things we don't need, standardize our data into a consistent format, and even make sure values are in the correct shape. For example, we might remove leading or trailing spaces, convert dates to a standard date format, or validate if an email address looks right. Let's look at a simple Python example showing how you can use regex to clean up whitespace. It's really quite powerful. Let's talk about how data analysts actually use the information they find. Think of it as a really important cycle. It all starts with gathering data from everywhere: databases, spreadsheets, even online sources. Then we need to clean that data up, checking for errors and making sure everything's consistent. Next comes the analysis phase, where we dig deep using statistics and charts to spot trends. Once we've found something interesting, we turn it into a report or a beautiful dashboard so everyone can understand. Finally, and this is key, we use those insights to make actual business decisions and improve things. It's not just about collecting data, it's about using it to drive real change. Let's talk about telling stories with data. It's not enough to just present numbers, you need to connect them to a bigger picture. A good data story starts by establishing the context. What problem are you trying to solve? Then, you present the relevant data clearly and concisely. But the most important part is highlighting the why behind those numbers. What does it mean? Finally, you should always conclude with an action item. What should people do based on this information? Okay, let's talk about interactive dashboards. They're not just static reports, they're like your data command center. A dashboard brings together key metrics in a way that's easy to understand at a glance. It's built with components like widgets, think charts and graphs, but the really powerful part is how you can interact with them. Filters let you zoom in on specific areas, and interactive elements allow you to drill down for more detail when needed. Basically, they make complex data accessible and easy to use for making decisions. Okay, let's talk about how data analysts really need to understand what they're working with. It starts with metadata. Basically, metadata is like a description of the data itself. Think of it as data about data. It tells you where your information came from, what type of data it is, and who's responsible for keeping it accurate. We'll cover things like the source, the data type, whether it's numbers or text, and the schema, which basically describes how all the pieces fit together. Trust me, good metadata makes a huge difference in your ability to confidently analyze and use the information at hand. Okay, let's talk about making your Excel dashboards really shine. We're focusing on slicers and timelines, powerful tools that transform static data into interactive insights. Slicers are like super filters. They allow users to instantly narrow down what they are seeing within a dashboard by selecting specific categories or time periods. You've got date slicers, category slicers, and drop-down slicers, each offering different ways to filter your data. And then there are timelines. These aren't just charts. They dynamically adjust to show trends and changes over time, making it super easy to spot patterns and seasonality. Think of them like a visual timeline showing how sales have grown month by month. Mastering these two elements is key to building dashboards that users actually love to explore. Okay, let's talk about anomaly detection. It's a really important part of being a data analyst. Basically, we're looking for things in our data that just don't fit the pattern. These outliers can be caused by all sorts of things, from simple errors like typos to potentially significant problems like fraud or even exciting new trends. We use different techniques. Sometimes it's simple statistical methods, other times we lean on machine learning algorithms, and sometimes we just use our knowledge of the business to set up some rules. Once we've identified these anomalies, the next step is usually visualizing them to understand what they are and then digging deeper to figure out why they happened. Okay, let's talk about building a really solid foundation for your data projects, creating a data dictionary. Think of it as a super helpful guide to understanding all the fields in your datasets. Why is this important? Well, it makes sure everyone from analysts to engineers and even business stakeholders is on the same page regarding what each column actually means. It reduces confusion, promotes consistency, and really helps teams collaborate effectively. A data dictionary typically outlines things like the field's name, a clear description of its purpose, the type of data it holds like numbers or text, possible values, and any important notes about how the data should be handled. Okay, let's talk about enterprise reporting standards. Think of them as the rules of the road for data analysts. They make sure everyone is on the same page when it comes to reports and dashboards. We're talking about things like who owns the data, how we name tables and columns so everything makes sense, clear definitions for all our terms, pre-designed report templates, and even guidelines on how to visualize the data properly. Ultimately, sticking to these standards helps build confidence in your work and supports better business decisions. Okay, let's talk about securing your business intelligence, specifically with role-based access control, or RBAC. Think of it like a security system for your data. Instead of giving individual users direct access to everything, we create roles like data analyst, report viewer, or even executive. Then, we assign people to those roles, determining what they can actually see and do within the BI tool. It's a fantastic way to boost security, make sure you're meeting compliance requirements like GDPR or HIPAA, and simplify managing access for everyone on your team. For instance, a data analyst role might be able to dig deep into sales figures but wouldn't have permission to change customer information, keeping things safe and organized. Okay, let's talk about predictive analytics. It's a really exciting area in data analysis where we move beyond just looking at the past and start trying to guess what's coming next. Basically, we use information from the past year historical data combined with some cool math and statistical methods to forecast future events. We're talking things like predicting if a customer is going to leave you, how much sales are likely to be for next quarter, or even spotting fraudulent transactions before they happen. There are several techniques used: regression, which helps us see relationships between variables; time series analysis, great for trends over time; decision trees, these help us make decisions based on data; and neural networks, a more complex method that's becoming increasingly popular. Okay, so we've covered describing and diagnosing data. Now let's dive into something really powerful: prescriptive analytics. This is where things get proactive. Instead of just telling us what happened or why, it helps us figure out what to do next. It's like having a strategic advisor built on data. We use techniques like optimization, which finds the absolute best solution; simulation lets us test different scenarios; and recommendation systems give us personalized advice, really helpful for things like marketing campaigns or product development. Okay, let's talk about data mining. It's essentially how we dig for hidden gems within massive amounts of information. We use various techniques like association rule mining to find relationships between items, clustering to group similar things together, classification to put data into categories, and regression to predict future trends. It's a powerful toolbox that helps data analysts uncover valuable insights. Okay, let's talk about managing your data projects effectively. Think of a data project like any other project. It needs structure. We start with initiation, figuring out exactly what you're trying to achieve, who's involved, and setting clear goals. Then comes planning, creating a detailed roadmap. How long will it take? What resources do you need? And most importantly, what data are you going to work with? We use tools like Gantt charts to keep track of things. Next is execution. This is where the actual data analysis happens. But don't just dive in. It's super important to constantly monitor your progress, manage any risks that come up, and make adjustments as needed. Finally, when you've got your findings, we close out the project by documenting everything, sharing the results, and evaluating if it met our initial goals. A little planning upfront can save *** of headaches down the road. Okay, let's talk about how we work together on these data projects. Collaboration is key. It's not just about getting the right answers, but sharing those insights effectively with others who need them. Different people bring different strengths to the table, and working as a team really helps catch errors and ensures everyone's on the same page. Now, version control is absolutely vital. It is like having a time machine for your data scripts. It lets you track every change, revert back if something goes wrong, and easily collaborate with others. GitHub is where you host those Git repositories, making them accessible to your team. Think of branching. It's like creating a separate timeline for your work, so you can experiment without messing up the main project. Commit regularly with clear messages, and always use pull requests to have your code reviewed before merging it in. Mastering these tools makes managing complex projects much smoother. Okay, so let's talk about some real-world challenges you'll likely run into as a data analyst. First up, dirty data. Think missing information or inconsistent formatting. It's super common and can seriously mess up your analysis. Next, make sure you know exactly what you're trying to achieve before you start looking at the numbers. Without clear business objectives, you'll just be wandering around aimlessly. Then there are data silos. That means information is spread out across different systems and it can be tricky to pull everything together. Choosing the right tools for the job is another big one, as there's a huge selection out there. And finally, don't forget about communicating your findings clearly. You need to be able to explain complex data in a way that everyone understands. Okay, let's talk about what data analysis is really making a difference. It's not just about crunching numbers, it's about solving real-world problems across tons of different industries. Think retail companies are using data to figure out why customers stop shopping with them, and then sending targeted offers to bring them back. In healthcare, analysts are looking at how patients move through hospitals to streamline processes and reduce wait times. And in finance, they're spotting fraudulent transactions before they even happen. Even manufacturing is getting in on the act. Data from equipment sensors can predict when something might break down, preventing costly downtime. Okay, let's talk about what's really hot when it comes to data analytics right now. 2024 is going to be a huge year for innovation. First up, generative AI tools like ChatGPT are already starting to help us automate parts of the analysis process, making things faster and more efficient. Next, we're seeing a massive shift toward real-time analytics. Businesses need insights now, not in days or weeks, so they're dealing with huge amounts of streaming data. Then there's explainable AI. It's all about understanding why an AI model is making a specific decision and building trust. Finally, organizations are moving towards more flexible architectures like data fabrics and meshes to handle the ever-increasing complexity of their data. Thank you for watching.